Okay, good day everyone. So today we will learn about linear function, which is part of subchapter 1.3 of MA 1103 Business Mathematics, and I am Reno Majunta. Okay, so remember, before you have learned about function, how to represent a function in three different ways, with equation, with tabular data, and with graph of the function. We will learn about a special kind of function which we call the linear function. So what is a linear function? A linear function is a function that changes at a constant rate. So the change of the function is constant with respect to the independent variable, usually x. Okay, the change is constant, always constant. Okay, so because the change is constant, then the graph of a linear function is always a straight line, because if we have a straight line, the rate of change is constant. All right, and the equation can be written in this form, y equal to mx plus b, where m and b are constants. And if you remember the previous subchapter, you can see that this type of equation is a part of the polynomial function, right? Yeah. So linear function is also a polynomial function when n, or when the degree of the polynomial is equal to 1. All right. So remember, in a linear function, we have a constant change, and this constant change, is represented by what we call the slope, right? The slope of the line, okay? The slope of the line is representing the rate of change of the function. So how to count the slope of a line, And here you can see that we can only count the slope of non-vertical line. So vertical line doesn't have a slope. Okay, we can see why is that later on. So we just need 2 points on the line, 2 points, and then we can count the slope by finding the ratio of change in y with the change in x, So you can count it in this way: y2 minus y1 divided by x2 minus x1. Okay, so let's see these 4 examples. The first one, we have a line which increase, the line which increase, and you can see when it increase, if I take these 2 points here, for example, the change from this point to this point, the difference in the y will be positive, the difference in the y will be positive because it goes to this direction, and the difference in the x will also be positive because it goes to this direction, So if we take this point minus this point, it will be a positive number. So in this case, we have the slope will be positive, positive divided by a positive number, it will be positive. So if we have an increasing line, we will have a positive slope. On the other hand, if we have a decreasing line, we will have here the difference in y will be negative, so negative divided by positive, it will be negative. In this case, the slope will be negative. So if we have a decreasing line, the slope will be negative. So vertical line, remember, we don't have a slope, yeah? A vertical line doesn't have a slope. Why is it? Because there is no difference in x, yeah? The x here doesn't move, yeah? It stays in one point, the x. So the delta x will be 0. And remember, we don't have a division by 0. It is undefined, and that's why the slope of a vertical line doesn't exist. But for horizontal line, what happened in horizontal line? We see that there is no change in y here. There is no change in y. The y keeps constant. So we have delta y will be 0. In this case, the slope will be 0. Yeah, 0 divided by anything will be 0. Okay, so for horizontal line, the slope is 0. Okay, so based on the information that we have, we can have another equation for lines. Actually, we have two more equations of a line. Yeah, remember the general equation for lines is y equal to mx plus b. Yeah, so this one here. Yeah, mx plus b. So how do we get m and b here? Yeah, so m is actually the slope of a line. The slope of the line. Yeah, m is the slope of the line, and then what is b here? B is actually the y-intercept. Yeah, the y-intercept. So the point on the line in the form of 0, b. Yeah, so this is one equation. The second equation is the point slope form. Yeah, so here we need to know the slope and the intercept, and here we need to know the point and the slope. Yeah, so for example, if we know the line passes through the point of a certain point x0, y0, it doesn't have to be intercept. It can be any point as long as the point is in the line. And we know also the slope. Then we have this equation of a line. Yeah, y minus y0 equal to mx minus x0. Yeah, and actually this is a more general form than the first one, because we can also find the slope intercept form by using the point slope form. Yeah, so if we take the point here is 0, b, and then you substitute 0, b into this equation, you will get the first equation. Yeah, so if you're not good at memorizing, so probably just memorize one equation, which is the point slope form. Okay, let's see one example. So what is the equation of the line in this figure here? Yeah, okay, so we don't have so we have interception in y-axis, yeah, the y-intercept here, which is 0, minus half. Yeah, the interception is 0, minus half. Yep, and then we can use the slope intercept form. Yeah, what about the slope? Of course, we have to count the slope first. Yeah, the slope will be the difference in y direction divided by the difference in x direction. So if we say this is the first point and this is the second point, okay, so the difference in the x direction, the second point is minus half, yeah, minus 0, right, over the x here is 0 minus the x here is minus 3 over 2. Okay, so here we have minus half over 3 over 2, and we have here is minus 1 over 3. Okay, so now we have the slope, and then we have the y-intercept. So the slope intercept form will be y equal to minus 1 over 3x. The b is what? Minus half. Yeah, okay. So the point slope, what about the point slope? Yeah, if we want to use the point slope form, by using this value, yeah, of course we can find here y minus y0 is 0, yeah, equal to the same slope, of course, because it's the same line, x minus half. Oh, this is minus 1/2. Oh, yeah, minus 3 over 2. Yeah, equal to minus 1 over 3x plus, or is it minus? It's minus half. Yeah, so it's the same thing. Yeah, by using the two different form, we will get the same equation of a line. Okay, so it depends on you which form you like best. Yeah, but I remind you that the second one is a more general form. Okay, so that's the equation of a line. And so if we have two lines, we can have these two conditions of the two lines. Yeah, the first one is they are parallel, and the second one is they are perpendicular to each other. Yeah, so parallel, the figure on the left are two parallel lines. Here you have two parallel lines, and this happens when the slope of the two lines are the same. Yeah, okay. And then here we have two perpendicular line on the right. So here we have two lines which are perpendicular to each other. Yeah. And this happens when the second slope is equal to minus 1 over the first slope. Yeah. So this is the condition when we have two perpendicular lines. Okay, so let's see this example. Yeah, so if we have a line for x plus 3y equal to 3, find the equation of a line which is parallel through this point. Yeah, and of course, if we want to count, if we want to find the equation of a parallel line, then we have to count the slope first. Yeah, so from here, the slope of L, yeah, we can say ML, M of L is what? Yeah, how to count it? Of course, we have to change this equation here into the slope intercept form of a line. Yeah, so here we have 3y is equal to minus 4x plus 3. Yeah, and then here we have y is equal to minus 4 over 3 x plus 1. Yeah. In this case, we have the slope of L is minus 4 over 3. Okay, so now because the line L1 is parallel to L, then of course the slope of L1 is equal to the slope of L, which is equal to minus 4 over 3. And then we can use the slope point form to find the equation of the line L1. Yeah, so we have the equation y minus 4 equal to the m x minus 1. Yeah, now of course you can simplify this one. Yeah, you can simplify. All right, so that's the first question. The second question is now you want to find the equation of a line which is perpendicular now. Yeah, so because it is perpendicular, then the slope will be minus 1 over the other slope. Yeah, which is what? Minus 1 minus 4 over 3, and this is equal to 3 over 4. Yeah, okay. All right, so now what is it? We can use also the same form, yeah, to find the equation of L2. Yeah, so y minus 3 equal to 3 over 4 x minus 2, right? And then you can simplify this one. Okay, so that's about parallel and perpendicular line. Okay, and the last topic will be about application of linear function, because if you see the linear function, oh, that's a very simple function. Yes, it is one of the simplest function exists. Yeah, but even though it is very simple, yeah, but it can be powerful. Yeah, so for example, it is often used for forecasting. Yeah, it can be used for forecasting. People have used it for forecasting. Okay, so suppose we have like set of data, yeah, or a data set. Then if we want to find a linear function which is best represent or best fit to the data set, then one of the method that we can use to find that linear function is called linear regression or least squares. Yeah, of course we will not learn about this in this course, but you will learn it later on, I suppose, in the third semester, probably, when you learn about statistics. Or if you want to learn more about it, you can try to find it in YouTube, or yeah, yeah. Okay, so let's say we have this data set. So this is about 7 online stores, the sales, yeah, in 1000s, and also the online advertising in dollars. Yeah, so here from this data, maybe we can say, okay, if I spend more dollars in online advertising, and then I will get more sales. Yeah, okay, probably from the data is not very clear, but we can try to uh, plot this data. Yeah, so you can see here the horizontal axis is the online advertising in dollars, and the vertical axis is the monthly sales. Yeah, and you can see in general, as the online advertising dollars increase, yeah, the monthly sales also increase. Yeah, you can see. Yeah, so if we have online advertising dollars is in here, then the sales is here, and so on. Yeah, okay, so now you know that, okay, when I spend more dollars in online advertising, the sales will also increase, right? But now you want to quantify, you want to know how much the increase will be. Yeah. Okay, so one of the way to answer that question is by using linear function. Yeah, so here we want to use linear function for forecasting. Yeah. So then we try to find a linear function, a line which is best fit this data set. Yeah. Okay, so if you use the linear regression method or the least squares method, you will find it. Yeah, you will find it. Yeah, so if you use simple linear regression, you will find that the linear equation that best fit the data set will be this one. Yeah, how to find it, you can learn it later on, or if you want to learn it now, go to the internet and find what is the simple linear regression. Okay. All right, so if I draw it, it will be something like this. This is the line, and this is the data set is still like what was drawn before. Okay, so okay, yeah, it seems like it represents the data, yeah, and actually it is the one that best with the data. Yeah, it can be proved that if we take another line, it will not be as best as this one. Yeah, so this one is the best fit. Okay, so here what does it mean? Yeah, what does this equation mean? So we have the slope is 171.5. Yeah, okay, so the slope is 171.5. What does it mean? It means that each increase of 1 unit in X, or in online advertising, yeah, we can say that the average increase of Y, or the monthly sale, will be 171.5, right? That's the meaning of a slope. Okay, and then if we translate that, yeah, if we translate that to the problem, we can say that this formula, or this linear equation, estimates that for each increase of $1 in online advertising, then we predict there will be increase in sales by 171.5. That's not too bad, right? You spend $1 in advertising and you will get sales increasing by $171 something. Okay, so that is one application of linear equation, which is called the simple linear regression methods, or least square methods. All right, so what we have learned in this subchapter, we have learned about linear function, we have learned about the slope of a line, equation of a line. There are two of them, but maybe you have just to memorize one of them. There are parallel and perpendicular lines and their properties, yeah, depending on the slopes of those lines. And that's all for today. Thank you for your attention. I'll see you in the next video.